You're very welcome. There's some stuff over there to pick up. There's someone's planner, someone's lab book, and 2 tests for unit and period 2. So oh, you have no idea how many you're going to get. Well, you're going to make. Please put your phones in the lab. Phones to the lab, guys. Come on, group 1. Check out. Group 2. Group 5. Sorry, I didn't realize you're 5. I wouldn't. Yeah. 7.
Good morning, Woodford High School. Each software comes always. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. I vote to clear the moment of silence. Announcement. The Woodson Bills Project has a story competition where students can submit a story to be used as a script for a production year. The deadline is October 31st, and there are no requirements for genre or content besides keeping things fairly school appropriate. You can submit ideas from Mr. K in room B211 in grade form. And just make sure your name is on the submission. We may be reaching out to you. Programs for sale October 17th to 26th during lunch for Relay for Life. Send a bootgram to someone to be delivered on Thursday, October 27th during learning seminar. Buy 1 for $3 or 2 for $5. Use Hamrock if you have any questions. For our rest visit today, we have William and Mary at 8:45 in the auditorium and Binghamton University at 2:15 in the Career Center. You like candy, costume contests, and meeting new friends? Well, you're in luck. The Woodson Valley Halloween Party has all that and more. Join us after school on Wednesday, October 26th at 3:10 on the blacktop. Costumes are optional but encouraged. We can't wait to see you there. Reminder, 8 opt-out forms are due in 2 Thursdays today. Want to show your teachers how much you appreciate them? Get them a teachergram. Check out the scrolling slides or flyers in the hallways and use the QR code to get them a teachergram. They are due by October 25th and will be sent to the teachers on October 28th. Interested in serving on this year's Honor Council? Then come to one of the training sessions, Tuesday, October 25th during 8 to 10, or Wednesday, October 26th at 3:10 p.m. Both sessions are in room B143. See Mr. Jeffrey for more information. Join MSA for our second meeting Tuesday, October 25th. We'll be playing a fun and loving trivia game. Come to see you there. Hey, Crowd, we have 2 cancer awareness games this week. Come out and support volleyball in their annual day game Thursday night at 7 p.m. Friday will be a cookout at school meeting up to football game versus Robinson at 7 p.m. Work in and support your tabs this week. We will have a girls basketball meeting on Wednesday, October 26th at 3:15 p.m. in room B116. All students interested in playing girls basketball should attend this meeting as we'll discuss important information about it. Where were you 10 years ago? Most likely running around with your fingers glued together. If you had been instead been considering the power of compound interest, perhaps you would have been invested in Tesla's initial public offering. An investment of $1,000 10 years ago would have been worth more than $170,000 today. That is a lot of waffle fries. To learn more about stocks and investing, come to the Investment Club's next meeting after school Tuesday, October 25th in A127. Bring your own waffle fries. Founded in 1994, the ACE Mentor Program of America is a free, award-winning after-school program designed to attract high school students pursuing careers in the architecture, construction, and engineering industry, including skilled trades. If being a part of that program like this interests you, please join us for an interest meeting on October 26th in room L122. This program meets twice a month on Wednesdays after school from 4:30 to 6 p.m. That's it for now today. Have a great day, Cav.
Yay. It's Friday. Welcome back. It's good to see you. Got the Wally weekend coming up. Festival of Lights, celebrating light's triumph over darkness. That works on every level. And, you know, you get to decorate your house with a bunch of twinkly lights, which is super cool. And the food's amazing. But anyway, I digress. We are starting unit 3. Everyone should have copied the card for today. Hopefully you copy word for word, because you normally have to know this word for word, because there's no really other way to say it other than with more sentences. But basically, when you arrange the elements in increasing atomic number, there is a periodic repetition of properties. Periodic repetition of properties. Periodic repetition of properties. Periodic repetition of properties. When you arrange them in order by atomic number, there's a periodic repetition of properties. There's a periodic repetition of properties. That is known as the periodic law. I'm still working on my law, because apparently anyone can get a law. Like the periodic table has its own law. I think we all should have a law. Right? Wouldn't that be cool? Like to have your own law? Just make it up. Periodic tables law. 3 handouts. The first little handout, the little tiny ones, was per student request. So I wish I could remember who requested this, but I don't. Someone did. And I starred the ones you have to memorize. And if it's just a minus sign, that's -1. Right. So they're sorted by charges: -1, -2, and -3, and +1. So hopefully you find this helpful. Because did you see on Schoology you're gonna have another polyatomic ion quiz? Okay. Super cool. Super cool, super cool, super cool. Okay, so hopefully you like that. Whew. So unit 3. Can't believe we're on unit 3 already. It's really my favorite unit. Except for the gas one, because that's just funny. Gas is just funny. It's my favorite unit because we have so many cool things to do in lab. But not today. Sorry. Today you will be making students. So you're going to make your periodic table of the elements. So you have a blank copy. You picked up yet another blank copy. On the last blank copy, you did electron configurations. Yes? You're not writing the elements. You already have a copy that has the elements on there. But you are going to add a whole bunch of stuff to this. And your resources are 2 sets of notes, one of which you have a copy of, and a video, which is on Schoology, actually, and one more source. Write this on the top of your notes. your notes. P table, little p, little t, a, b, l, P table. Oh, let me check. I don't know, is it .com or .org? Let's see. Hold on. ptable.com. ptable.com. So this is ptable.com. And across the top, it's called ptable. You have a properties tab. You have electron tab. Oh, that's going to look familiar. The electrons tab. You have an isotope tab. Wow, that looks familiar. And every atom has isotopes. How do you see them? Ooh, you just click on the atom. Look at all the isotopes of aluminum. How many carbon isotopes? Look at all the isotopes of carbon. Right? Oxygen. Look at all the isotopes of oxygen. And then you can, do stuff with it. So, and then you have compounds, which we will get to. And that's when you drag and drop elements. Have one of those and one of those. And you try to make stuff. And you haven't made anything yet. But if I do this, do I make anything? No, I haven't made anything yet. That's not a good thing. Do I need to add that? Yeah, I need to add that. What else do I need to add? Maybe this. Can I add that? Oh, look now. And then it tells me what I'm at. Oh, wow. That looks really tungstopterin cofactor. This is just part of a tungsten. So it searches for something that has these elements in it. That's kind of cool, right? But again, we're not using that tab yet. Whoa, wait a second. Why does that look like that? Okay, there we go. Here, if we look at the properties tab, we can see one different periodic repetition of properties. All of these have similar properties. All of these have similar properties. Those do, those do, those do, those do, those do, those do, and those do. So now you don't get one of these guys on a test. So you're going to have to learn this on your own, like where they are on the periodic table. And a good way to do that is to kind of color code your own. So this is a kind of a cool little source. Now that's just if we did properties. You also still have this. Look at those orbital diagrams. Right? It just fills it in for you right in order. Don't you wish I had shown you this before? It's just awesome. It does every last one for you. Anyway, I don't know. It's not mean of me really, but oh, wait. Oh, look and see, it even shows you the shape of the orbitals. Right? It changes the shape of the orbitals between where you're. Oh, look at that orb. Oh my gosh, look at the D block orbitals and see how it, up in the corner, it's showing you the orbital shape. Right? How funky they look. Okay, anyway, ptable.com is another source. Do not include elements. You have one for that. This is to differentiate other information on the table. And the notes that you have here just kind of introduce this to you. Not something crazy, a little bit of history. You need to know Mendeleev. That's how you say that name, Mendeleev. He was the first to arrange elements. He arranged them in order according to mass. According to mass. Is that what the periodic law does? No, it arranged them in order of what? Atomic number. Okay, so he did really awesome for what he had in 1869 by arranging elements by mass. And he even saw the repeating pattern by mass, but it didn't hold up until we learned more and we could arrange them by atomic number. And then this just shows you, just arrange them by mass, and he noticed, oh, hydrogen acts like fluorine, which acts like chlorine, right? That's the repeated patterns that come up. So lithium and sodium and potassium, the repeated patterns. So it kind of told us how to make the table. Now, let's go on. You have all this, who actually confirmed Mendeleev, not too important. So first, you need to be able to identify metals, nonmetals, and metalloids. I think with your white one from the state of Virginia, metals and nonmetals are pretty easy because it has the stair step, and you're not going to lose that stair step. So concentrate on where the metalloids are on the stair step. So they are not including aluminum. They're either above, like standing on the tread, or under the tread. That's the tread is the flat part. You know, it's rise, run. So it's on the rise or under the rise for every element except aluminum. So it kind of helps you with that. And then you're going, so you have the group of metals. So you know what is a metal. Take a few notes on what makes something a metal, right? What makes something a metal. So put these in as descriptions of what makes a metal. And a metal, like what makes it a metal. You already kind of know if they lose electrons, they become the cations or the positive charges. Then the nonmetals are described. And there are only 17 nonmetals. And then like here, it says one is a liquid at room temperature. So bromine, if you notice on the periodic table in the classroom, bromine is blue. And that's indicating at room temperature, it's a liquid. On the periodic table, what other element is a liquid at room temperature? Hg, which is mercury. So those are the two elements that are liquid at room temperature. What are the red ones? Those are gas at room temperature. And so then all the black ones are solid at room temperature. Absolutely. And the clear ones are not quite confirmed as when this was printed, right? But remember, they're made in a lab and they're only around for very small periods of time. So don't get hung up past 92. Because it's through 92 that you really should be responsible for. And then what makes something a nonmetal? What makes something a metalloid? So these are just definitions. You want to paraphrase these notes. The big thing that should be new is the periodic table is split into main group elements. And main group elements follow the periodic law really, really strictly, really, really well. Those are main group elements. And so we kind of give them the term A. So here, and see, you can't color the whole thing, right? So somehow main group elements, they include multiple things, but the yellow shade on here is the main group elements. So super duper follow the periodic law. Meaning in this family, they behave, group 1 all behave, group 2 all behave the same way, 13, 14, 15, up and down the group, same chemical properties, same physical property, not exactly the same, but very similar properties. So we rename those as A. See the A up top? Why is that black thing going like that? I just want the big, hold on. See the A? 1A, 2A. Then it's 3A, 4A, 5A, 6A, 7A, and 8A. So we give the main group elements A and we just label them straight up. Now notice the B is what we call the transition elements. And these guys don't necessarily follow as strictly, but look how this is gone. It's 3B, this always freaked me out, 4, 5, 6B, 7B. All three of these are in 8B. Right? They took 3 columns and made it 1 column. Mankind can do anything they want. Then it stops at 8B. There is no 9B. This is 1B and 2B. So, right? So this is 3. It started at 3. Here's 1 and 2. Look, 11 and 12 are the 1 and 2. 11 and 12 are the 1 and 2 for the B. So sometimes you'll see periodic tables numbered that way, and often they'll use Roman numerals for these. Sometimes they're Roman numerals. But I just think that complicates it even more to do Roman numerals for those. Make sense? But if you color your whole thing like this, then you're not going to be able to color your thing like this. And then you're not going to be able to color your thing, even more importantly, like this. Does that make sense to you guys? Yeah.
So some of them aren't colored like the last and like 10%.
These guys right here,
And then just all that.
they're the ones in the lab. So, well, gray is kind of a color. Right up Mediterranean, slate unknown, ionization first, radius is not like it doesn't even know how big it is. It doesn't even know its melting point or boiling point. We don't know anything. We don't know jack about that guy. Yeah, just leave those. Like we don't know jack. And you are responsible through number 92 is natural. Well, then you got, Berkeleyum and Californium. Those two get used a lot just because of Berkeley, California. They're all excited that they got elements named after them. Has anyone ever been to Berkeley? Yeah, right? Do you think they deserve elements named after them?
Probably.
Yeah. Kind of cool. So yeah, so don't worry about those guys for coloring. Now, so this goes through what we just did on there, describes some noble gases, describes alkali metals. And then notice it's using group 1A, group 2A. It's going to describe halogens. And then we just did ions, and it's talking about main group metals. Main group metals, so that's A. Main group nonmetals, so that's B groups. And what ions they tend to form. This is very good information to have. Very good information to have. Now, I told you not to put element symbols on there, but I would like you to add, make sure you add it in the right place. Aluminum, oh my God, move that guy. Aluminum is +3. So you may write in aluminum 3+. And then just diagonal to that, zinc is 2+. And then just diagonal to that, silver is 1+. So there's a lot of, not a lot. There are several exceptions that you don't need to know about at this level of chemistry, but this one is good to know about. And if you can remember, aluminum is 3, right? It's in 3A. It's going to form a +3 ion, then it's +2 and +1 diagonally. 3, 2, 1. That's how I remembered it. 3, 2, 1. 3, 2, 1. 3, 2, 1. 3, 2, 1. What's this guy right here? What's diagonal from silver? Mercury, right? So this guy is however you want to do it. I don't know. You could do like wavy. That guy's liquid at room temperature. I don't know. But I don't know. What you do you. I would probably do water waves or something. And this guy's wavy. But these are the ions. -3, -2, -1, +1, +2. You don't have to put the symbol. but they're all +1. You don't have to put the symbol, but these guys are all +2. These guys -3, -2, -1. You don't have to put the symbol. Notice that hydrogen can be either plus or minus. Hydrogen's so special, super special. So there is a tremendous amount of notes. That's molar mass. Stop about here. Tremendous amount of notes in this one, but on Schoology, let's go ahead and there is another one. There's another note packet for you, and there is a video. Do you want to watch the video as a class? Yeah, that'd be cool. So here. In 1959, the Harvard mathematician Tom Lehrer recorded a song that would become the anthem of a great people.
Hydrogen and oxygen and nitrogen and radium. Secondly, on the uranium, germanium, and iron will be uranium, uranium. Tritium, terbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, strontium, and silicon, and silver, and samarium, and bismuth, chromium, lithium, beryllium, and barium.
Oh my God, this is so cool. We got to start over. You guys need the whole experience. Would you hit the lights? Either one of you, ladies, please. Just put all 4 of them off. Come on, the whole experience, guys. And then I got to turn it up.
There's antimony, arsenic, aluminum, and selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, and terbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, chromium, lithium, beryllium, and barium.
Barium. Sorry.
There's holmium, and helium, and hafnium, and erbium, and phosphorus, and francium, and fluorine, and terbium, and manganese, and mercury, molybdenum, and magnesium, dysprosium, and scandium, and cerium, and cesium, and lead, praseodymium, and platinum, plutonium, palladium, promethium, potassium, polonium, and tantalum, technetium, titanium, tellurium, and cadmium, and calcium, and chromium, and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, plutonium, and radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Yeah, that wasn't the song. I mean, that wasn't the video. You want to watch it again? What do you mean that became an anthem? Yes! Oh, look, another one. This is for singing along. Phosphorus, francium, fluorine, and terbium. erbium, manganese, mercury, molybdenum, manganese, dysprosium, scandium, cerium, cesium, lead, praseodymium, platinum, plutonium, palladium, potassium, polonium, gadolinium, titanium, tellurium, cadmium, calcium, chromium, curium, sulfur, California, fermium, berkelium, Einstein, Nobel, argon, kryptonium, radon, zinc, silver, chlorine, cobalt, copper, tin, sodium. Okay, we totally need to try that, right? Okay, as a group, we're gonna, it's like for sing along. Haven't you ever done karaoke? These are the words to karaoke. Okay. Antimony, arsenic, aluminum, selenium, hydrogen, oxygen, nitrogen, rhenium, nickel, neodymium, neptunium, germanium, iron, americium, ruthenium, uranium, europium, palladium, lithium, osmium, acetine, radium, gold, protactinium, indium, gallium, iodine, thorium, thulium, and thallium, yttrium and actinium, boron, gallium, niobium, silicon, silver, samarium, bismuth, bromine, lithium, beryllium, barium. Chromium, helium, hafnium, erbium, phosphorus, francium, fluorine, terbium, manganese, mercury, molybdenum, manganese, dysprosium, scandium, cerium, cesium, lead, praseodymium, platinum, promethium, potassium, plutonium, lutetium, tellurium, cadmium, calcium, chromium, and curium. Sulfur, Californium, fermium, berkelium, einsteinium, nobelium, argon, krypton, neon, radon, zinc, chlorine, carbon, cobalt, copper, sodium. Has come to Harvard, and there may be many others, but they haven't been discovered. I appreciate you leaving me out there, guys. Totally just leaving me out to hang. Yeah, so that's not the video on Schoology. I was just joking with you. This is the video on Schoology, the modern periodic table. It's almost as fun.
Hi, friends.
Hi, friends.
In this video, we look at the last stop in our journey, the modern periodic table. Remember in the previous videos, we discussed the early attempts to classify elements. That is the Dobrivinius triads, Newton's law of octaves, and Mendeleev's periodic table. Here we're going to look at the modern periodic table, but we are going to do it in a different and interesting way. So rather than starting with the periodic table, we're going to start with a blank table. We'll
That's what you have.
as we go along in this video. I'm sure by the end of the video, you'll be a master of the periodic table. And as usual, we'll finish off with our 3 questions on this topic. Normally, when you draw a table, it looks something like this, with rows and columns. But if you take a look at our periodic table, it has a strange shape, and we are going to see why. As I said, we'll start with a blank table, and we're going to fill it up as we go along in this video. Since our focus is only till the 20th element, which is calcium, so we'll be looking only at the first 4 rows of the periodic table. Let's call this our mini periodic table. We'll talk about the lower rows later on in this video. So I'd like you to pause the video here and go ahead and sketch our mini periodic table in your notebook. Just draw this blank table till the 4th row. You can also pause the video here and do a print screen and take out a printout of the blank table. Friends, are you ready with your blank periodic table? I'm going to magically shrink myself so that you can see the table better. And let's fill up this table together.
I wish I could do that.
First, let's start by numbering the rows. So it's going to be 1, 2, 3, and so on. In our mini periodic table, we have only 4 rows, but the full table has 7 rows. Rows are called periods. So these are period numbers. Similarly, we can number the columns. So the column number is going to be 1, 2, 3, and all the way up to 18. Columns are called groups in the periodic table. So these are our group numbers. There is a different numbering scheme for groups as well. We'll look at that later on in the video. Next, start numbering the boxes. So start from 1, 2, finish the first row, then go on to the second row, 3, 4, 5, and so on. These numbers look like serial numbers or row numbers. But do you know what they really are? That's right. They are atomic numbers. Atomic number is defined as the number of protons present in the nucleus of an element. This was the major difference between the modern periodic table and Mendeleev's periodic table. Mendeleev's table was based on atomic mass, but the modern table is based on atomic number. So you may be wondering why. Because the scientist Moseley proved that atomic number is a more fundamental property for elements as compared to atomic mass. So the chemical properties of elements are more related to their atomic number than their atomic mass.
You're filling in,
Let's-
not
let's start
just
with
these
the
three are
elements
special.
in our table.
So
So you know which is the first element?
Well, not
And
whatever
atomic
you
number
said.
one,
You're gonna.
which is proton in the nucleus.
And
That's right. The correct answer
Figure
is
out-
hydrogen.
all kinds of.
So that's from the symbol of hydrogen H in the first place.
Yeah.
Next with atomic number 2,
You don't sit back and watch
helium.
and see what.
And
So
now
how it
let's go
goes.
to the second row. So there we have lithium,
So you're
vanadium,
not filling this out like he is. You just sit
Oxygen.
back and watch.
hydrogen, chlorine,
You'll learn
and
stuff.
neon. And I want you to fill up all the way till element number 20. So that is till calcium. With every element that you fill in here, the atomic number is increasing by 1. So what does that mean? 1 extra proton is being added in the nucleus. Now, how is the electron number changing? What do you think? That's right. The electrons are also increasing by 1. Because remember, an atom is neutral. It has equal number of protons and electrons. And note, we are not concerned about the number of neutrons right now. Now let's talk about the significance of the period of the row. So in our mini periodic table, we have periods from 1 to 4. But remember, in the full periodic table, you have it up till 7. So what does this period number tell us? It tells us the number of electron shells or electron orbits present in an atom. So we can predict the number of shells without even drawing the electronic structure. So let's take some examples. Hydrogen is in period 1, so it has only 1 shell. Now, if you look at oxygen, it's in period 2, so it contains 2 shells. So similarly, how many shells does aluminium have? That's right, 3 shells, since it's in period 3. And what about calcium? Correct, 4 shells. It's in period number 4. So with every new period, 1 more shell is being added. Now let's verify this by looking at the electronic configuration of a few elements. Let's show the electron configuration of hydrogen. It has atomic number 1. So just 1 proton and 1 electron. And as you can see, it has only 1 shell. Next, let's look at oxygen. It has atomic number 8. So that's 8 protons and 8 electrons. So if you draw its electron configuration, the first shell will have 2 electrons, since it can hold maximum of 2. And the second shell has 6 electrons. So as you can see, oxygen is in period number 2 and it has 2 shells. Next, we have aluminium with atomic number 13. So the electron configuration is going to be 2, 8, 3. So aluminium in the third period has 3 shells. You can draw the full electron configuration, or you can write it in this simple comma notation, 2, 8, 3. And let's also look at calcium, which is in the fourth period with atomic number 20. And as you can see, its electron configuration is 2, 8, 8, 2. So as expected, calcium in the fourth period has 4 shells. Now let's discuss the significance of the group. We always try to group similar things together so that it's easy for us. A simple everyday life example is the grocery store, where you'll find similar things grouped together. For example, you'll find all the vegetables together, salt and sugar on one side, and all the chocolates in one place. Now imagine you walk into the grocery store and everything is scattered. You go crazy while shopping, right? Similarly, in the periodic table, elements having similar chemical properties are grouped together. Now let's take a closer look. If you look at group 1, except for hydrogen, all the elements in group 1 are metals. They are called alkali metals and they have similar chemical properties. They have the same valency 1. Now let's look at group 2. Once again, we see there are metals in this group. They are called alkaline earth metals. And they also have the same valency. Now let's move ahead to group 70. If you look at this group, it contains non-metals. And they have the same valency 1. Now an interesting question is, why do elements in the same group have same valency and similar chemical properties? What do you think? The answer lies in how the electrons are arranged in the atom. That is the electronic configuration. So let's go ahead and analyze the electronic configuration of elements in the same group. Let's start with the group 1 elements: hydrogen, lithium, sodium, and potassium. They have atomic numbers of 1, 3, 11, and 19. Now let's try to write down their electronic configuration. Hydrogen is simple. It just has 1 electron. Now lithium has an atomic number of 3. So it's going to be 2, 1. Sodium will be 2, 8, 1. Potassium is going to be 2, 8, 8, 1. So can you see what these elements have in common? That's right. They have just 1 electron in their outermost shell. So that's 1 valence electron. So all these elements have the valency 1. And why do they have similar chemical properties? Because chemical properties depend on the number of valence electrons, which is same for all these elements. Now let's look at group 2. Here we have beryllium, magnesium, and calcium. Similarly, let's write down their electronic configurations. So beryllium with an atomic number 4 is going to be 2, 2. Magnesium, which has an atomic number of 12, the electron configuration is going to be 2, 8, 2. And calcium, which has 20 electrons, is going to be 2, 8, 8, 2. So once again, you can see all these elements have the same number of valence electrons, which is 2 in this case. So they have the same valency, 2, and hence they show similar chemical properties. In summary, we saw that elements belonging to the same group have the same valency and similar chemical properties because they have the same number of valence electrons. Now, the group numbering that we saw from 1 to 18 is the new scheme. There is an older scheme that uses Roman numbers and alphabets A and B. Let's take a look at the old scheme as well. As we have seen, the new scheme has group numbers from 1 to 18. Now let's look at the old scheme. Group 1 has the number 1A. Note 1 is written in Roman numeral and the alphabet capital A. 2 is 2A. Now when we go to group 3, it's tricky. It's going to be 3B. Then you have 4B, 5B, 6B, 7B, and groups 8, 9, and 10 have the Roman number 8. Then group 11 is 1B, 12 is 2B, and then when you move on to 13, it's 3A, 4A, 5A, 6A, and group 17 is 7A. And the last group, group 18, has the number 0. The new group numbering scheme is much easier to remember than the old one. But it's important to know the old one as well, because sometimes it's used. Now I can teach you an easy trick to remember the mapping between the new and the old scheme. Basically, you have till calcium in your syllabus, element number 20. So if you take a look, you have group 1, group 2, and then group 13, 14, 15, 16, 17, and 18 in your syllabus. You don't have the groups from 3 to 12. Now, if you look at the old scheme, so what you have in syllabus is 1A, 2A, and then 3A, 4A, 5A, 6A, 7A, and group 0. So basically, only the A groups are in your syllabus and group 0, which is the noble gases. The B groups and group 8 are not in your syllabus. So I hope that helps you remember the old scheme. We have a lot of details in our periodic table. Now let's go ahead and add some color. You might have seen these colorful pictures of the periodic table, where the colors represent the different types of elements. For example, metals, non-metals, noble gases, and metalloids. So are you ready to start coloring our periodic table? First, let's color the 4 broad categories of elements: metals, non-metals, metalloids, and noble gases.
What do
Now
you
our
guys
periodic
call
table
this?
Looks more colorful, right?
A legend
You
or
might
a
have
key?
seen some other
Yep.
periodic tables
You gotta
which
include
have
that.
more colors and some different colors in different groups.
Look at the metalloids. If this is your stair step, I don't know, I can't draw on this. This is the stair step that you have, right? So it's above and below the stair step for everything but aluminum. So aluminum's not included, but silicon, germanium, what's AS? And SB? Serbium, right? And TE, tellurium, PO, polonium. It's almost like I can hear the song in my head. Should we play the song again? Is this making sense to you? I know it's kind of remedial, but what do you think about the electron configuration? A little easier than what we did? Yeah, but you really need to know the SPDs and Fs. It's important for later. Okay, I'll keep going.
Groups, like this picture here. So let's go ahead and take a look at some of these groups because they have some special names. The group 1 elements are called alkali metals because these form strong alkalis with water. The group 2 elements are called alkaline earth metals because they form weaker alkalis as compared to the previous group. Now moving on to group 13. This group is called the boron family because boron is the first member in the group. Similarly, group 14 is called carbon family, and then you have group 15 as nitrogen family, and group 16 is called the oxygen family, or also known as chalcogens, which means ore forming. Now group 17 is called the halogen family, and the last group, group 18, are known as noble gases or inert gases. Till now, our focus has been from element 1 to 20. So till calcium. Now let's go ahead and take a look at the full periodic table. In the complete periodic table, we have 7 periods or 7 rows and 18 groups or 18 columns. Now, if you look at period 6 and 7, you'll notice something interesting. That elements with atomic number 57 to 71 and 89 to 103 are put separately below the periodic table. This is done to compact the periodic table. The elements 57 to 71 are called lanthanide series because they start with the element lanthanum. These elements are rare earth elements. And elements from 89 to 103 are called actinide series because they start with the element actinium. These are radioactive elements. Now let's discuss the merits of the modern periodic table. The merits are that it corrected the anomalies in Mendeleev's periodic table. Now, how did it do that? Because Mendeleev's table was based on atomic mass, but the modern table is based on atomic number. It's based on the modern periodic law, which states that the properties of elements are a periodic function of their atomic number. So let's take a look how the anomalies of Mendeleev's table were corrected. First, let's talk about isotopes. Isotopes are atoms of an element having same atomic number but different mass number. They have identical chemical properties. Now, isotopes could not fit into Mendeleev's periodic table. But in the modern periodic table, they fit in nicely because they have the same atomic number. So isotopes of an element belong in the same position as the element. And that makes sense because they have same chemical properties. The second point is Mendeleev had to make certain exceptions for some elements, but these are fixed in the modern periodic table. For example, the position of cobalt and nickel. Cobalt should come first because it has a lower atomic number as compared to nickel, even though it has a higher atomic mass, because the modern periodic table is based on atomic number. Even though hydrogen is placed in group 1, it's given special treatment. Many times it's shown broken off from group 1. Now, why is that? Because hydrogen shows properties that are similar to group 1 elements, that is alkali metals, and also group 17 elements, that is halogens. So since it shows properties of both these groups, it's given special treatment. Friends, I hope you feel that you have mastered the modern periodic table now. Remember, practice.
Have you mastered it? Not yet, but you will, right? Okay, so the rest of class is yours to work on this table. And you can use your computer to open up the second set of notes, which goes through and describes the groups and their properties, especially when we get over to here, separate from the alkali and the alkaline earth. From this guy, you should definitely get the rare earth elements for the name of your lactinide series and radioactive for your name of your actinoid series. So each source gives you a little bit different information, and of course they repeat some information. You want to look at 3 sources and combine what's missing from the different sources. We can start with any source you want, and you need color pencils. There is color. And if you screw up, you can get another. Yeah, I have. Yes. So go to one source, whichever one you want, maybe the paper notes, and add as much as you can. Huh? Yeah. That was fine. If you're gonna start with the table, start with that. But when you highlight alkaline metals and you have a key that says alkaline metal, you have to tell me about an alkaline metal. So you get that from these notes. You know, now these notes don't have 13, 14, 15, and 16. So you get those from the other notes there, but you like what makes the oxygen family the oxygen family. So what are the properties that make that? And then this is a tool for you. This is a tool for you. Somehow, and you can write in the blocks if you wanted to take the notes kind of up the column. You know, you could do that to kind of fit them. We're not at that sort yet. But we will be when we go into matter. So you have a copy of the first one, the second one you don't have a copy of. There we go.
Next. I love the best.